of Chapter 2 involves the last tool that you'll need for taking derivatives. Everything from this point on, after we finish that, will just be fun time. Okay? Today's lesson will involve a number of examples. It's not a very long lesson, but the examples that I have will take a little bit of time to work through. And then when we're done with that, I will pass back the last couple quizzes. On those, you will find on Schoology, I've created assignments to record those scores. I've attached the answer keys to those. I would suggest you spend some time looking at my answer key compared to your quiz. Then, asking questions for clarification on the stuff that you had trouble with. Yo.
Are these notes on Schoology?
They should be, are they not?
I don't see it. I don't know.
The teacher may have dropped the ball and not unlocked the aforementioned notes. Hold, please.
Everything was going well. And my teacher was getting so upset about it. Because like the airplane wasn't working.
What? Yes? I think so. Oh, I dropped the ball and did not publish them. I am doing that right now. And you will find these notes listed in the folder. Okay, so implicit differentiation sounds scary. It is. But it solves a simple problem for us, and that is everything we've done up to this point, all of our functions have been in the form y equals blah, 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 blah in terms of x. Or f of x is equal to blah, 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 blah in terms of x. What if the problem that we're trying to take the derivative of, you can't solve for y? Yeah, that's kind of scary. Well, I've got a method to do that. However, let's warm up with this guy. Go ahead, I'll wait.
Uh-oh.
You don't have to like it.
So, gosh.
This isn't a popularity contest.
No, it's really not.
Yeah.
We had a creative burst of energy this morning.
Everything was, it's going bad today for everyone.
This isn't going bad.
No, it's not. The first that was on Schoology. Technological issues. My first period class was so, my teacher needed to take a break more for him than for us.
Really? I've had those days.
It
I've had those
happens.
days.
It happens.
That's right. Conrad, while you're working, what derivative technique are you using for this problem?
Chain rule.
How many functions are there, Conrad?
3.
And how many chains would that entail? 2. Beautiful. Keep
Yeah.
working.
That's a helpful advice.
I have no clue how to do
That's what I got.
The last one. But you just said
Okay, now is it?
Just like negative sign. Yeah, for cosine. And then you keep the x. Yeah.
I'll talk you through it. And then click on the little pen there on the bottom. Good. Choose a color. You don't have as many colors as you can do.
I like red though.
You like red? All right. Go crazy.
Wait.
How many chains did you tell me? 2. Okay. How many chains have you done? 2. This is all you've only done one. Oh. That's a derivative. You got one chain. I'll do another chain. Nice. You good?
Should I
Take that
simplify
pen
it?
on the front. What's the matter?
Should I simplify it?
No, just leave it like that. Who cares? All right, there we go. So, a couple comments. Number one, I like the way you move. I don't know why I'm yelling at you right here. I like the way you move the squared out in front. It sometimes makes the function easier to see. 3 functions. They are the squared function, the cosine function, and the polynomial on the inside there. Then again, the question you want to ask yourself is which one is the outer layer of the onion? In this case, it's the squared function. You take the derivative of that thing inside, bring the 2 down, reduce it by 1. And notice you just rewrite that function inside. Then you take the derivative of the next layer of the onion, which would be the cosine. Okay, my minimum criticism is this is a little wonky over here. I might have done this just to be sure. Okay, other than that, it's great. Take the derivative of cosine to be negative sine of that stuff. That's one chain. Then chain on the second part, which is the 3x squared minus 4. Okay, good. Notation is good. Change to f of x first. Don't need any new notation there. But then as soon as you start taking the derivative, you've got some new notation there. Preguntas? No? Yeah. Okay, so today, we're going to use implicit differentiation to find the derivative of a function. That's it. Well, I lied. There's one more thing. Please, whenever possible, understand the difference between there, and there.
What is
Okay.
this spacing?
I don't know what's with the spacing there. And don't spell them that way. Don't leave a gargantuan gap between the Y, the apostrophe, and the R. 4 steps. One of the things that we use is the notation dy dx. We've talked about this ad nauseum. The derivative of y with respect to x. I will show you a shortcut instead of writing dy dx every time to make your life a little bit easier. We'll get to that in a minute. Okay? So we'll talk about, number 1 is going to be the tricky part of this lesson. Okay, taking the derivative with respect to x. Well, what if I got y's in there? That gets a little wonky. We'll get there in a second. Steps 2, 3, and 4 are all just algebra. Number 1 is the only calculus involved, believe it or not. So if you want to, you can do 2 steps. 1, differentiate. 2, do the algebra stuff to solve for dy dx. Now the big difference that I like to use is instead of using dy dx, we have this other notation that says that is the same thing as y prime. I like to use y prime because it's less to write out. However, if you like dy dx, then stay with it by all means. They're the same thing. Okay, we ready? I'm stretched out, I'm ready to go. Here we go. Now, if it were a simple equation, and you could solve for y, then we wouldn't be bothering with this gunk. But I don't know about you, I'm pretty good with math, and I'll tell you one thing I can't do is solve that for y. I literally don't know how to. I'm sure some math nerd would be able to do that. I just don't know how to do it. So we want to be able to take the derivative without doing that. There's a rule that you need to remember that will make your life really easy. Anytime you take the derivative of a y, you have to attach a y prime to it. That doesn't make any sense right now, but once you see me get after it, you will understand what I'm talking about. I'm just going to take the derivative. Okay? So, there's no notation. I'm just going to start working with this puppy because I have an equation. So when you take the derivative of y cubed, you take the derivative just like you would take the derivative of anything else raised to the 3rd power. Molly, what's the derivative of y cubed?
3y squared.
Good. 3y squared. Now I say to myself, I just took the derivative of a y, so therefore I have to attach to it a y prime. If you don't like the y prime, then put a dy dx there. Again, same thing. Catherine? You with me?
Yes.
What's the derivative of y squared?
2y.
Beautiful. And I took the derivative in terms of y, in terms of x of a y, what must I include?
Wait, can you repeat that in terms of x?
You just took the derivative of a y. What do I have to include?
The y prime.
Good. I got the next one. Derivative of 5y is 5. But I took the derivative of a y, so I stick a y prime on there. What's the derivative of x squared? 2x. No y, so it just goes 2x. And believe it or not, the biggest mistake that people make in implicit differentiation is the following. What's the derivative of negative 4?
0.
Nice. Good. But one of you knuckleheads is going to take the derivative of negative 4 to be negative 4. And one of you might be an overachieving knucklehead and take the derivative of negative 4 to be negative 4y prime. Just to make things interesting. Okay? Done with the calculus. Questions so far? Yes, sir.
Why don't we have an x prime? Or is it just the y's?
Oh, great question. I'll give you an easy answer, and I'll give you a technical, fancy schmancy calculus answer.
Just in case they switch up the variables and be like, where's the y?
They won't.
Okay.
Because we're taking a derivative with respect to x, we don't need an x prime.
Okay.
Or another way to think of it is, y prime is the same thing as dy dx, the derivative of y with respect to x. So if I did it over here, I would take the derivative of x with respect to x. Oh, what's that equal to?
1.
Yeah, 1. Okay. So we're done with calculus. Now we do some algebra. Algebra is really simple. Get all the y prime stuff on one side, move all the other gunk to the other side. Well, that's easy. 3y squared y prime plus 2y y prime minus 5y prime equals 2x. Again, algebra 1. Factor out a y prime. Whoops. What am I doing? Can't even do the algebra. That's a good one. Step 3. Get the y prime by itself. All done. That wasn't so bad, was it? No?
I'm sure it's gonna get worse.
Of course it is. Yes.
Always does.
I'm lulling you into a false sense of security. Oh, it's going to be easy. Don't worry about it.
That's true.
Yeah. But again, I want to make sure that you understand the basics before we move on to the next example. And I make your life a little bit more difficult. Like, for instance, oh, I don't know. What if I wanted a second derivative of that?
We just.
Oh, yeah. Oh, that's about to happen. Yeah. Second derivative. Take the derivative of the first derivative. What would that involve? Quotient rule. Here we go. Y double prime is equal to big gazinta bar, denominator squared. Bring the denominator up to the top. Times the derivative of the numerator minus big honkin' bracket. Numerator times derivative of the denominator. 6y y prime plus 2y prime. That's not so bad, right? I'm sorry for the following question. Eric, what's y prime? Easy. Let it find it itself.
Y prime was just there.
Yeah. Well, you don't have to do anything. This is America. Right on. But if you're going to do this correctly, now the nice thing about the second derivative is notice I don't have to solve for y double prime. However, I do have to get rid of that y prime. I'm going to do the substitution. We're not going to do the simplifying. Unless you want to. I mean, we can.
No, we're okay.
Well, let me show you what it looks like first. Oh, you're not crying yet. Hold on. Funny part is that it's going to be on the video. All right, let's see. It goes there. Close this off. Let's suppose, hypothetically, I was going to simplify this. You wouldn't. It is physically impossible. How would I go about simplifying this in the most efficient manner? Crying is not an option. Luke?
Multiply everything by 3y squared plus 2y minus 5.
Close. Can't do that. That would change the value of the problem. You're so close there. Somebody else talking? Yeah. Good. In case you didn't hear, multiply by what Luke said, 3y squared plus 2y minus 5 over 3y squared plus 2y minus 5, because that's equal to 1. It won't change the value. What would happen if I did that? Well, it would do the following. It would turn this into a squared. It would get rid of that. It would get rid of that, and it would turn this into a cubed. Now, you might be saying to yourself, that's not much clearer. Yeah, but we got rid of denominators inside denominators, or fractions within fractions. Okay. At this stage, I would be happy if you could get to the original red. Okay? Second derivative. Now, what do you think's coming next? Third derivative. No, different one. Yeah, I wouldn't do that to you. I wouldn't do that to you. Yeah. Half of you would be running out of here looking for drop forms.
It's too late.
Well, you can still drop.
Yeah.
You just get an F. Yeah. Okay, so let's make things a little bit more interesting. Usually that sentence is followed by throw some trig in there. I'm not going to do that to you. We're going to do something simple like this. Look at how easy this is. Lily, easy. What are the two things you need for the equation of a tangent line?
You need a slope and a point.
Slope and a point. Do we have a point?
Yes.
Easy peasy. How am I going to go about getting a slope?
Okay, so you'll take the derivative of both sides.
Okay, good, done, that's it.
Yeah.
I'll do the work. That's all I was looking for. Good, we're going to take the derivative. And that'll give me some big scary formula. That's okay, because we know the point, we can plug and chug. Taking the derivative of this guy is a little interesting though, because you'll notice over here, ooh, what's going to happen there? Say it again?
More y prime.
Yes, but how would I get there? How do I take the derivative of that? Nobody?
Product rule.
Product rule. Hey, what's going to happen over here?
Chain rule.
Chain rule. Oh yeah, that's about to happen. Okay, so let's go. Let's see. 6 times the quantity x squared plus y squared times 2x, derivative with respect to x, so therefore no x prime, plus 2y y prime, close parentheses. Let's stop there for a breather. Everybody good? Two functions, one chain. Equals, the 100 doesn't matter, I'm just going to put it there to stay out of the way. Throw in some parentheses. The first times the derivative of the second. Derivative of y would be 1. I took the derivative of a y, so I take a y prime, plus the derivative of the first, which is 1, times the second, which is y. Okay, take a second to let that percolate, if you will. If you look at that monster, it would not be fun to solve for y prime here. So therefore, I'm not going to. What? How is that possible? How can you finish this problem if you don't solve for y prime? What's x equal to? 3. What's y equal to?
1.
Let's plug and chug. Go.
Okay.
Plug and chug. Figure out what y prime is. Do those number stuff. Don't be bashful about busting out those calculators.
Yeah, we are starting.
Can you pick up on the sarcasm there?
Yeah. Yeah, so you add it to the 9. Because it's in the same. It's 10. Yeah.
Oh.
Eric, you okay? Where'd your y primes go?
Yeah.
Yeah, that's what.
Thank goodness they make erasers.
Wait, what?
Did you cheat or did you just happen to get the same answer?
Oh, she was using her.
But I like we were doing it, but then I asked her.
You shared notes.
But then I asked her what 260 meant.
Fine, let me go see what the other components got.
I am 15 over my share.
I know that you didn't go with the rest of the year.
So,
Yeah, a little bit.
I got 360 plus 120 lifetime. Because 300 times 100. Wait, would you get? Now you solve. One.
It's not cheating, it's a usual calculator. Oh, you're such a rebel. You're gonna hospital because it requires you bending over the phone.
Wait, you're gonna get like a price.
Favor. Fraction.
That's not?
I'm sorry.
It is.
Yo, you got it, boys. This is math is like.
There seems to be a consensus, and that consensus is 13/9, yes?
Yes.
Outstanding. So this is a particular case where you can make your life a lot easier by understanding what you're trying to do. I don't really care what y prime is, equation-wise, I care about it numerically. So by doing all the math, we end up with the slope being, is it positive?
Yeah.
Positive 13/9. Which means y minus 1 is equal to 13/9 times the quantity x minus 3, and we're done. Okay? Good. Mistakes are going to be made. One of the first mistakes that you're going to do, which happens all the time, is you're going to forget to attach y primes to any time you take a derivative with respect to y. The other thing, and the reason I did this example, is you're not going to realize that that's a chain rule and that's a product rule. You could also see something crazy like a quotient rule. What's the derivative, for instance, of 2x squared equals x over y? Now, would you do implicit for that? No, you'd solve for y and just take the derivative. But if you had to, that would be a quotient rule. Okay? We're done. How many of you see that picture moving? Okay, just checking.
Wait, what's it mean? If you look like in the middle, it starts moving.
You look in the middle of the year.
It moves on that one, but it's not.
Really?
Yeah, it's
Look around the room. Do you see it moving on different monitors and not moving on others?
Well, it's moving on.
Oh, moving on all. Okay.
It's not moving on that one. It's moving on the others.
Awesome.
I feel like we can put a whole thing.